Yes, we come back to part 3, which is basically the continuation of part 2, the sums only. Okay, that means the complex number sums we are going to continue. So we get another sum if a plus ib equals to x plus I whole square. By this, to x square plus 1, then we have to prove this part, a square plus b square. So as I told you, and what I was telling you earlier, that we can use the properties of modulus and the properties of the conjugate of complex number. So in that way the sums will be done, they can be done much more easily and shortly. Okay, so what we do here, we apply here quickly the property. So we mod both sides. So basically I write this. Okay. So obviously this side, you see, after modding this will come a square plus b square. And look at this side. This is something x plus I whole square. So I can write x plus I mod and that square. And since the denominator has no I in it, that means it is not a complex number. So mod will have basically no effect on it. Why? Because mod of 5 is 5, like that. So mod of 2x square plus 1 will be 2x square plus 1. So here there is something happening, that the square is going outside the modulus. So now if I write here beside what is going to happen, that is mod, if I write, it's x square plus 1. Why 1? Because I into 1, that is the b part, and square it, and below it's 2x square plus 1. Okay, so that means this is basically x square plus 1, below it's 2x square plus 1. Okay, so the entire line I solved. Okay, entire thing I solved in one line, so that it's actually reduced. Now I will square both the sides. I will square this and I will square this. So both the sides, if I square this, I will get the answer. So that means squaring both the sides, I get a square plus b square equals to square of that. That means x square plus 1 whole square, and below it will be 2x square plus 1 whole square. But I suggest you, please write the properties whatever you are using over here. That means all those properties I told you earlier, z1 by z2, mod of that is broken into z1 mod and mod of z2. So these properties you write, and this is proved. Okay, so we go to the next sum now. Okay, I wrote another two sums. So the first one is, it's a product of few factors given, 1 plus I, 1 plus 2i, 1 plus 3i up to 1 plus ni is equal to x plus iy. So you have to prove this, the product of 2 into 5. These are not, don't consider them dots, like these are products. Dot basically means products. 2 into 5 into something like up to 1 plus n square. Product of all these will be x square plus y square. Now the clue is, please see this, x square plus y square. So whenever you see this x square plus y square, immediately you know that this comes by modding this x plus iy. That means the mod has to be done on the both side of this given expression. So if I mod it, this expression, that means 1 plus I, then 1 plus 2i, then 1 plus 3i, the whole thing I write. Okay, so basically I am modding both the sides. So you know, these are all these products, this will be broken into like this, so many mods, mod, this mod, then product of this mod, then all the mods, then last mod, and this side it will be root over x square plus y square. Okay, now inside the mod, what to be written? These things, these factors. That means 1 plus I, 1 plus 2i, 1 plus 3i. All these things has to be written till the last term 1 plus ni. Now each of these mod, look at, I'll mark it with another color so that it's a little visible. Say this, okay, this thing or this thing. So each of these mods, okay. So resolve them into the mod formula, whatever we know, that is root over what? 1 square plus 1 square, which is 2, root 2. Now this is 1 square plus 2 square. Now this is 1 square plus 3 square. I hope you are getting how this is coming out. Now the last one will be 1 plus n square, and that is equal to root over x square plus y square. So when you square it, that means square both sides, you get the answer. So if you square it, this root is removed, this becomes 5, this becomes 10, and all this, till this root will also be removed. Okay, so this side it will be x square plus y square, and you got the thing which is to be proved. So this is number 13. Now number 14 is something like x is given something and evaluate, we have to find the expression, the value of this expression. Now the main point is that please do not ever think of putting the x value direct into this expression, because if you put this x into it, it will be like such huge that obviously you make a calculation mistake over here. So don't even think of that we will substitute with minus 5 plus 2 root over minus 4 over here, there, and expand. Then it will be some 1 hour will be left. So let us work it out with a little this. Then x plus 5, if I shift this 5 to this side, this becomes root over minus 4 means it becomes 2, and root over minus 1 it becomes I. So basically it becomes 2i. That means it becomes a 4i. Okay. That means it becomes like this. X plus 5 is equal to 4i. Okay. So if I square it down, I get x plus 5 whole square, which is x square plus 10x plus 25. Okay. So that will be 4i whole square. That means 16i square, which is minus 16. Now if I move this thing to this side, I'll get x square plus 10x. Okay, I'll write it nicely, then it will be equals to minus 16. Okay. Then if you move this minus 16 to this side, you will get a factor which is x square plus 10x plus 41 equals to 0. Okay. So I will use this x square plus 10x plus 41, okay, into the expression again and again, because that is 0, so I can use it. So I'll try to use that over there. So what I'll do, this expression I am writing, look at it, equals to so this is a kind of 3 lines which go together. So x square plus 10x plus 41, I multiply a x square. Why so? Because I want to get a x4 over here. So I got a x4. Then I got what? Plus 10x cube. Why plus 10x cube? X square into 10x. See this thing, if you have not done earlier, you won't understand in one line, in first time. So please see this video again and again. Okay. So these 2 lines has to be written together. Okay, once I write this line, then you cannot understand. Okay, so please go back and see what I am doing. Okay, so why did I do this 10x cube? Because I cannot stop the multiplication. Once I have written x square over here, it has to be 10x cube, and then what else? 41x square. But look at it, it's 10x cube is originally not there, it was 9x cube. Okay, so to make it 9x cube, I have to subtract x cube. Now this is x4 is okay, 10x cube minus x cube, 9x cube is okay. So what I will do, I will use the factor again. Look at it, I will use the factor again. Now point is, why I am using this factor? Because value I know. This factor is 0. Value I know, that's why I am using. I prefer to use this factor. So the value will become 0. X square into 0, then something will be 0. Like that. So I got x cube over here, then minus what? Minus 10x square. Then minus 41x. Look at it. Now the x cube problem is solved. Okay. Now look at x square. 41x square plus 41, then minus 10. So you got a 31. Okay, 31x square, but here it is 35. So you need another 4. So I got to have another 4x square with it. So if I get another 4x square, it can be seen. Yes, still it can be seen. So another 4x square I need. Okay, so to get a 4x square in the second line, I need to multiply 4 into x square plus 10x plus 41. Okay. So my x square problem is also solved. How? 41x square minus 10x square, which is 31 plus 4, 35. Now problem lies with minus x. Okay. Now as I have written this, I have to write here what? 40x. Okay, because 40, and here I need to write what? 164. Okay. Now look at it. 40x and minus 41x. So minus x problem is solved. But 164 is too much. Here there is only 4. So I have to write minus 160. But since I write minus 160 in this line, I have to write a minus 160 in the next line also. Okay. So that means here you get what? Here you get x squared dot 0 minus x into 0 minus 4 into 0. Why this is 0? Because this is 0. I am taking this value, putting this value over here. Minus 160. So the value of this expression is becoming minus 160, which is the answer of this. So I advise you, go back to this again and again. Okay, this is one line. I did not have space so I need to write over here. So please go back to it again and again and see it. Next we will proceed. So here we get a sum which is very important. First of all, this is in NCERT miscellaneous. Please find it. Okay. It's given alpha, beta are different complex numbers. That means anything can it be. It can be x plus iy or a plus ib. Different complex numbers. So mod b is given as 1 and you have to find this. Okay, so nothing is given, so only mod b is 1. So we start like 1 minus lambda bar, means it's a conjugate of this. We start by squaring this. Okay, why so? Because here look at it. We can use a formula which is mod z square, it's z into z bar. So this is a property. I have given you this property. Please see this if you have forgotten. So in that way it will be a product of two things. Okay, look at it. Similar to this, z into z bar. You get a product of two things. One is beta minus alpha 1 minus alpha bar beta. Another will be beta minus alpha by 1 minus alpha bar beta. Okay. Now, if you get this, you can actually multiply this too. Okay. you can multiply this two. So how before multiplying, what I do, I will apply the once again the property to it. So I get a beta bar minus alpha bar over here, and below I get 1 minus alpha into beta bar. So what exactly I did? I did like something like I have given to this particular thing, since this is a whole bar, that means if I apply this property, that means Z1 by Z2 whole conjugate. So this will be Z1 conjugate by Z2 conjugate. Okay. So now beta minus alpha whole conjugate by 1 minus alpha bar beta, that is also whole conjugate. So when you apply the whole conjugate, this becomes what? Beta bar minus alpha bar, and when you apply the conjugate over here to 1 minus, then again this thing, that means alpha bar which is alpha and beta bar. Okay, so this thing becomes this. So that's why this ultimate this thing I put over here. Okay. So this is the part. Now what I will do, I will multiply. Simply we will multiply. We will get beta into beta bar. Okay, minus alpha into beta bar minus alpha bar into beta, then minus alpha into alpha bar. So this thing I will get. Now below also I will get 1 minus alpha bar beta I write over here, alpha bar beta. Then okay, then what to get? Then alpha beta bar, that means this one, and this one will be plus alpha bar beta bar. Please look at it. I have multiplied 4 terms only. Now beta bar. What is beta bar? What is beta bar? Beta bar is beta mod beta square as per the first property. So this is given as 1. Why? Because mod beta is 1. So here we can put beta bar which is as 1. Why 1? Because beta bar is mod beta square which is 1. Minus alpha bar beta. This thing is still alpha, or you can write something like alpha square, mod alpha square you can write. Now below denominator is exactly same, 1 minus alpha bar minus alpha bar beta. Okay. Then plus alpha bar becomes this thing, and beta bar becomes 1. So basically this beta bar becomes 1 and alpha bar becomes alpha whole square, mod alpha whole square. So this is 1. So square of this quantity 1. So that means individually beta minus alpha by 1 minus alpha bar beta, it implies that this will be also 1. So this is the answer. If the square of the mod is 1, that means individually that will be also 1. So this is the answer. Okay, so next part we will do some more things. Thank you.